In this video, we're going to be talking about the Coriolis effect. The Coriolis effect is the curving of the Earth of objects or fluids due to the Earth's rotation. So, let's say I have a ball, and let's say I'm just going to be remaining stationary or just in one position. So, let's look at this example. If I were to throw the ball in a straight line, the ball would obviously go in the straight path and would hit the wall. Now, if I were to rotate while throwing this, then what would happen is that ball, since I was throwing it straight, if I were to do the exact same object but rotate while I'm doing that, what happens is the ball's trajectory changes and it appears as if it's going curved. So I'll demonstrate that. As I was rotating here, I threw the ball over there. The ball still went in a straight direction, but since I was in a different position, it looked as if it was curving. Now, obviously, since you're over there, it doesn't look as curved, but if you were overhead, you would be able to see as it was curved. So now we have the camera at a satellite position. The camera is going to be rotating, so it's not only going to be capturing Earth's movement, but it's also going to be able to capture the Coriolis effect at the same time. So now we're going to start it in 3, 2, 1. So in that video where I was throwing the ball to demonstrate Coriolis effect, we were taking it up on a satellite perspective. By looking at it overhead, when I threw the ball straight, what happened was and when the camera was turning, what happened was it looked as if it was rotating a little bit to the right, as you can see from that slow motion picture over there. So through that's actually how the Coriolis effect really works. What happens is, even though we're throwing it straight, because of the Earth's rotation, or in this case, the camera rotating, it tilts a little bit to the left or a little bit to the right, or clockwise/counterclockwise. We're also going to be demonstrating this through a piece of paper. What happens is, on this piece of paper, the wind, it typically goes in this direction over here. But since the Earth is moving, it's going to be rotating. So I'm going to be drawing the exact same line over here, but with the Earth rotating, just like we demonstrated in the previous experiment. The camera is rotating. I still threw it straight, but what happened was, because the camera was tilting, it made it look like it was curving to the right. So we're going to be doing it again. So I'm going to be turning it, so the piece of paper is going to rotate like the Earth, but the wind is still going to go, or the water is going to go in the same straight direction. So 3, 2, 1. All right, 3, 2, 1. So when I was turning it, even though I was still going in that straight line, what happened was, because the Earth was rotating, it created this pattern. Now I'm going to be doing it, so this was in the Northern Hemisphere. Now I'm going to be doing it in the Southern Hemisphere. So let's see what happens here. What I'm doing, like the previous time, I'm drawing the straight line, but the Earth is rotating along with it. So 3, 2, 1. Okay, so just from that, we could see how, even though I was still drawing that straight line, even though the Earth moved, it still went that way. So I'm going to be doing it in this direction instead of doing it through this direction. So instead of going through counterclockwise, I'm going to go clockwise. I'm going to rotate this thing clockwise. So we also saw how this tilted. This hand was in the way, but we also saw how this kind of tilted also. So I'm also going to be doing the same thing, but this time in the Northern Hemisphere. We also saw how that was tilting also. So this shows how the Coriolis effects also works over here. In the Northern Hemisphere, the direction of wind, or the direction of the water, like in oceans, tends to go clockwise, while in the Southern Hemisphere, that tends to go counterclockwise. And the reason why is because of the Earth's tilt. Earth tilts like this, so the sun rises in the east and sets in the west. So it tilts like this. It tilts like that. So since the sun is rising in the east over here compared to the west, it's going to move like this. Because I was moving this paper over here clockwise, this wind flow, or in other words, this line I was trying to draw straight, ended up also going along with that rotation. So just like that with the wind flow in the Earth, what happens is it tends to go in the direction. If it starts here, it tends to go into the direction that the Earth is rotating with. And in the Southern Hemisphere, it tends to go the exact opposite. It tends to go counterclockwise, like this over here. So it really naturally goes like this. And this doesn't just happen with wind, but it also happens with water at the same time. So that's how the Coriolis affects our Earth and affects our climate in multiple ways.